This experiment involves designing a first-order low-pass filter with a 10 kilo-ohm resistor and a 1 nanofarad capacitor. A signal generator provides a sinusoidal input, and the filter's transfer function is analyzed by measuring input and output at varying frequencies. Using the voltage divider rule, the theoretical transfer function, h of s equals v out over vn, is derived. Since Google Sheets can't handle the imaginary numbers, the transfer function is split into its real and imaginary components. The real part is 1 plus 2 times pi times frequency times resistance times capacitance, where r and c are resistance and capacitance. And the imaginary part is negative 2 pi frequency, r times c over 1 plus 2 pi, frequency, r times c squared. Both depend on frequency, showing h of s varies with frequency.
H of z can be rewritten in the form of a plus bi, which has a magnitude. That magnitude affects the output since y sub z equals h of z times x of z. The cutoff frequency is found to be 15.9 kHz for this filter, but the cutoff frequency's value is not the focus of the experiment. Using Python, PyVisa, and Matplotlib, we split frequencies up to 40 kHz. Below the cutoff frequency of 15.9 kHz, the magnitude of the transfer function is near 1, so y sub z closely matches x of z. Beyond the cutoff, magnitude of transfer function drops significantly, attenuating the output. The graph shows how the magnitude of the transfer function decreases with higher frequencies, showing how the filter gradually reduces higher frequencies rather than just eliminating anything above the cutoff frequency.
Now we will simulate a Butterworth low-pass filter using MATLAB. Here is the MATLAB code for the digital filter. This simple digital filter will read an audio file and apply a Butterworth filter with a specific cutoff frequency. Once the filter is applied, we will compare the original and filter signals by playing them one after another. For this demonstration, we will use one of our members' voices as the input audio. After listening carefully to both original and the filter signals, you will notice the difference. Alright, I'll start.
Hi, how are you guys? Hi, how are you guys?
Did you hear a difference? Yes. After applying the filter, the sound has noticeably lower pitches and sounds deeper. This is the effect of the low-pass filter removing the high-frequency components of the voice, leaving behind the deeper tones. Thank you so much for following.